Hi, all. Thanks so much for watching Making AI Work for You, bringing together the stars of medicine, venture, and AI and academia. I'm Stephanie Fields, the patient and family expert, also a philanthropy expert, and super excited to welcome Phil Koopman, PhD, associate professor at Carnegie Mellon University, and originator of UL 4600. He's also been working in self driving cars for 30 years. Next, we are welcoming Steve Wilson, who is the CPO of Exabeam, member of TTIC, advising on the LLMs, and author, and also an expert in machine learning, LLMs, cybersecurity. And he said he has been working in AI for since '92. So we have some really amazing conversations coming up. Next, Sherry Duville, CEO of Metagram, chair of the Trustworthy Technology Innovation Consortium, TTIC for short, series editor for Taylor and Francis, and has edited and co-authored a series of books that have defined the field of healthcare IT. Turning to Dr. Apoorv Gupta, who is my co-host and co-founder of Making Healthcare Work for You. He's a VP at Premier and also co-chair of TTIC. Thank you all for being here.
Thanks. Thanks for having me.
Great to be here.
You both have prolific histories in realms that most people are just talking about now. So with that, I'm actually going to start with something, Phil, you said in our pre-interview. And you said that the scope of safety completely changes when the humans are removed. So why don't you start with that? Because you're clearly an advocate of self-driving technology. You originated UL 4600, which is the safety standard, but still you recognize that human component. And as we apply that to healthcare, how does that scope change and what does that mean for us?
Sure. Well, let me start with something important, just so everyone starts at the same place. Nobody knows if robotaxis are going to be safer than human drivers. People all try and take that as a given. We don't know yet. Jury's still out. Need 10 times, 100 times more data before we find out. So despite what the headlines say, nobody knows. But why that is two factors. One is we don't have enough data, but the second is that what safety means changes dramatically when you remove a continuous attentive human operator out of the loop. So when you have a regular car, a car that may have self-driving capabilities, but there's a driver in the driver's seat who's told, hey, it's your responsibility to maintain safety. Part of what they're doing is they're doing more than just driving, and they're maintaining safety in more dimensions than not just hitting stuff. So people, how often do you have a crash? Well, there's more to it than that. The circumstances of the crash matter. So as a simple example, we're recording this on a super cold day, and down the road from me, there's a street with several inches of ice on it because a water main broke. And it's on a steep hill, not a street you want to go down, all right? And so you can say, well, I was driving down the street with 3 inches of ice and I lost control. It wasn't my fault. I crashed into a pedestrian. And the answer is, well, why did you ignore the police warning? This is hypothetical. I hope this doesn't happen today. Why did you ignore the police warning? Why were you stupid enough to go down a steep hill to go to 3 inches of ice? What are you thinking? And so part of safety isn't just driving skill. Part of it is being smart enough not to do stupid things to put yourself into the high-risk position you can't get out of. And part of it is not disobeying the road rules of bypassing police tape. There's a bunch of things that when there's, say, if we're talking healthcare, there's a physician who's supervising a piece of equipment. But that physician is deciding whether that's the right piece of equipment to use. They're deciding what mission that piece of equipment is supposed to accomplish, how to apply it, whether it's off-label use, all these kind of things. They're making all these decisions. Once you have a system that is completely autonomous, like a robotaxi, it is not only tasked with the safe tactical use, but it's tasked with all these secondary considerations that we used to delegate to a person. And so the scope of safety completely changes because all these things that used to be the person's problem, including all the way out to negligence, all that stuff, now this autonomous system is doing. And if you want to sue, by the way, suing a robot doesn't work because they don't own property and all these other things, right? So now it's like, well, who's even responsible for that? And if the answer is nobody's responsible, don't expect to get safe outcomes.
That's fascinating. And just a anecdotal bit of evidence years and years ago, 20 years ago, I had a surgery and I wasn't yet fully asleep in the operating room. And I remember seeing a machine that said auto cut. And I said, what is that?
Yeah.
They said, it's better if you don't look around. But on that basic fundamental level, if you have something like that that's making full decisions without human oversight, you can have very different outcomes. You do need that because everything is contextual. Like you said, you have to be able to find the visual guardrails that life is giving you.
And on a technical basis, what you'll see is the definition of safety usually has in a specified environment. Well, who's responsible for making sure you're inside the specified environment if there's no person? And in your case, patient fully sedated, I would imagine would be the specified environment. And if you're out of it, who's paying attention to that? And if it's a completely autonomous system, guess what? The computer has to do that. And many technical definitions of safety sort of don't address that. And one of the things we did in UL 4600 was say, yeah, the current safety standards are nice, but in a car, I liken it as I used to serve in the Navy, so I say captain of the ship. The car has a captain of the ship. The captain of the ship not only drives it, but they make sure the kids are in their car seats, and they make sure that if the car's on fire, everyone gets out, and they make sure of all these other, if the tire's low, they notice there's all these things you do that have nothing to do with avoiding crashes while you're driving. When you take out the human operator, who's the captain of the ship? You have to ask that question. And if you don't have a crisp answer, don't expect safety.
Yeah, that's really fascinating, Phil. I love this conversation because it's kind of related to one of my favorite topics, which is the changing face of safety because of the changing capabilities. Of course, technology, artificial intelligence. I like to think about it in my world in terms of the changing face of quality, constantly evolving because of what the consumers now are able to expect out of the healthcare system, in particular. So from that vantage point, I guess maybe we should broaden out that conversation to not only thinking about taking the human decision maker out of the equation, but also the context, the education that's been provided, the training, is potentially the organization that put that, that device together. Are they liable? So maybe we'll broaden that out. And I don't know if Steve, if you want to comment on that, or Phil, you want to jump back into that.
Yeah. I'm coming at this from a little bit different perspective than, say, like the self-driving car perspective that Phil's starting from, because I deal a lot more with sort of general IT technologies, which are also really important in healthcare. And one of the probably the hot trend for AI in 2025 is what they're calling agentic systems, and it's a really fancy word. But you have to unparse it, and you have to think about agent. Even when you get back to that, people are like, what does that mean? So you parse it back one more thing, and you're like, that's derived from the word agency. And when you talk about that, you're like, what agency am I giving to this entity? And it's the same as like a real estate agent. I'm allowing the real estate agent to go act on my behalf, and they have a certain amount of empowerment based on the agreement I have with them. And so one of the concepts that we talk a lot about in terms of safety and security of these systems is how much agency am I giving to the AI system? And we actually have this concept called excessive agency. And there's no absolute measure of this, but you have to think about the context in which you're using it and the capabilities of the system that you're using. And with these large language models, which is the technology that sits under ChatGPT and its friends, they are incredibly powerful and notably unreliable for certain types of tasks. So what you have to kind of do is step back and say, for the use I'm going to put this to, do I feel that the reliability of this kind of system is going to be in line with the rights and privileges I am giving to this system to act on my behalf? And not everything is a life and death decision, like a 4,000-pound piece of steel hurtling down the freeway at 70 miles an hour. So I might be able to give more agency to this type of system if what it's doing is helping with billing, and the worst thing that happens is I have to go and give someone a refund versus I ran over them with a car. Obviously, when we're talking about, medical devices in a care situation, there also is the question of like, how much is the doctor in the loop and being advised by the system versus, the system is able to actually directly provide care or intervene on behalf of the patient. And those things are going to have much different levels of agency and much different so-called guardrails that I will put around the system.
I just want to add that's brilliant commentary, actually, both Steve and Phil, and highly relevant to medical technology, not just devices, but the whole stack of infrastructure, interoperability, data, and then devices. And a lot of them are AI enabled right now, right? So I do want to just share with the audience that these individuals have been working decades in the field of safety and security and with AI, and that we have hundreds of experts in both the case of OWASP as well as IEEE UL 2933, which I have to talk about every time, being the full stack clinical IoT trust infrastructure standard. And so I do want to put a plug in for the tools of UL 4600, which is the autonomous safety standard. We don't need to reinvent the wheel in healthcare. And then with my standard IEEE UL 2933, it's not my standard. I'm just co-chair of trust. There's lots of other leaders in it. In fact, 317 people in 22 countries. But also Steve's OWASP group, like he said, is hundreds of experts. So my view is like we need to lean on that great work that's been done, because we don't want the field to become unmanageable. And so that's why this discussion, to me is urgent. And so I do want to punt it back to you just quickly, Steve, if you can briefly explain the title of your last Forbes article and then sort of how that ties into this discussion.
Let's talk about supply chains. The last few years in, I would say, software development in general, the thing that has risen to the top of the kind of security and safety concerns are software supply chains. And we've been talking about manufacturing supply chains and hardware supply chains for decades or centuries, and it's a well-studied field. In software, as we've moved to more and more complicated systems, you can't build them all yourself. You're taking piece parts from different places. As we went through the open source transformation in the last few years, or in the last decade or two, that's become even more complicated because more and more of the software, these days up to 80% of the software in a lot of systems, is taken from open source projects where you've never met the authors, you have no business relationship with them other than you kind of implicitly agreed to a license when you took the software, but it's completely self-serve, do what you will, no warranties. When you extend this to the AI place, we've moved into a place where all the old risks around supply chains exist, but it's infinitely more complicated and new. And so the basic software supply chains for open source are built around communities like GitHub, which are very well understood. There are tools that are well integrated in them that know how to scan source code and binaries and understand the provenance of them and help you make good risk decisions about what code you're bringing into your system. But even with that, we have disasters like SolarWinds and Log4j that have impacted large organizations. The open source supply chain is built around a site called Hugging Face, which is a relatively new community run by some really smart, passionate people around making sure that to some extent, AI is democratized, which is a really important part of what we're doing here. You don't want just this handful of megacorps that are the only place to get these new AI technologies. But these communities are really immature, and the tooling around them is immature. And when you think about these AI technologies, there are fundamental pieces that we never had to worry about before. It used to be source code and machine executables, and now we have things like model weights and training data, which we have not built good tools to analyze and say, where did this come from? Do I trust this? How do I understand what I am baking into my system? And so I frankly have just come to say that this is currently a raging dumpster fire. And researchers have gone out and done research where they have pulled hundreds of machine learning models off of Hugging Face that are full of active exploits like remote code execution and things like that. There are actively poisoned models out there waiting for you to build them into your system and give the hackers a backdoor into what you're doing. So I'd say that's one of the big areas that I'm talking about with software developers right now, is better understanding the risks of your supply chain, because there are. I mean, this is a space moving so fast, and you want to take advantage of the latest, greatest, and you want to experiment with it. But there's a lot of challenges around understanding the provenance and qualities of things you're getting from the supply chain, whether it's paid things you're getting from OpenAI and Google and Amazon, or free things that you're downloading and trying to self-execute. And we're all the way to the point where just in the last few weeks, we've seen these examples of these amazingly capable models coming out of China, where people are like, this is really exciting. This is really good stuff, but it's coming from China, and we don't really understand how they work. I mean, in a very literal sense. And it's like, how do I make a decision about, am I excited enough about the capability of what I'm getting, given the source of where it's coming from, that I'm willing to bake this into a system that's important to me?
If I can build on what Steve said, even if you are 100% sure there's nothing malicious and nothing untoward in it, which is a super big challenge, I completely agree. When you're done, if you have a lump of code or a lump of model weights or whatever, making it safe is a challenge, because nobody knows how to look at a piece of software and say that software is safe. You can say it's unsafe by finding the bug, but if you didn't find a bug, it just means you didn't find a bug. It doesn't mean it's safe. The way we get safety is by following rigorous engineering processes. And all the machine learning stuff I've seen didn't follow the processes when it was created. They're just trying to get it to work, and I get it. It's immature. They're trying to get it to work. That's great. But you don't really want to be in an airplane where someone says, well, there's the aviation safety standards, and they require the following engineering rigor of so many man years of effort on the flight controls, but open source, it'll be fine. Let's just go flying, right? And that's exactly what we're seeing with any embodied AI is the new buzzword. So this is what I do now. I do embodied AI, okay? Embodied AI, what you're seeing is software of unknown provenance, of unknown quality other than seems to work okay, and you shovel it in and you see what happens. Now, there are responsible ways to deploy it by using conventional, traditional software as a wrapper to keep it from doing something bad. But that's notoriously difficult to do for things like perception and prediction, which we don't know how to do with it without using machine learning. So the safety is also a dumpster fire. Sorry to break it to you. So security is a dumpster fire. Safety is a dumpster fire, because we're just shoveling this stuff in and let it rip and just somehow deciding that all the safety stuff we've been using for decades doesn't matter anymore. You see too much of that. Now, some companies are being very responsible. Some are trying really hard. But the fundamental thing is, if you don't know how to apply engineering rigor to get safety, you've thrown out the safety playbook, and you better have a really convincing story to tell, because you're not doing it the traditional way. And I suspect security is not so different.
Phil, you said that before in the pre-interview that safety is actually the first step to change, and that most people are aligned but don't even know what to ask. So tell us a little bit more about that.
Well, some of safety is, there's a thing called safety engineering, right? People say, well, I'll just do system engineering. I'll do some testing. Testing never proved anything was safe. Testing on a bad day for you will prove you're unsafe, but testing doesn't prove you're safe. Because and I'm going to use automotive numbers just because they're more every day, and I happen to know them. But it's about 1 fatality per 100 million miles on U.S. roads, with a bunch of hand waving average, right? So I went 10 million miles without a fatality. You're not even 10% of the way there. That means nothing, right? And the numbers are literally beyond human comprehension. How many people drive 100 million miles? So intuition doesn't help you with safety. Safety is all about the extremely rare events with very high consequence. And the environment you're in determined how rare is rare and how consequential is consequential, but it's all about the small things. Machine learning is all about the average. Statistical is about average. So it's just a mismatch. So if you line these up, you have to ask yourself, okay, so I ran 100 tests, I ran 1,000 tests. That doesn't get you anywhere for safety. It seems to work. There's obviously broken, and then seems to work okay. And then safety's way off the screen. Safety is way the heck up here. And how do you get there? Well, testing almost never gets you there because you can't afford to test it. The way you get there is by following rigorous engineering safety standards, which UL 4600 doesn't tell you how to get there. It tells you how to know you got there. The difference matters. How you get there is still work in progress. But when people say, "Oh yeah, we've used all the best AI techniques, so we're sure it's safe," the answer is, "Really? Explain to me exactly how you know that's safe." Because a lot of the AI techniques, and you're using the latest open source software full of security exploits, you're not there. So it can be done. Using a pure AI approach, it's extremely difficult to get safety. Using a hybrid approach, you have to have a story for making sure, even if the AI acts in a bad way, how are you still making sure safety is there? You can definitely do that, but you have to think very carefully about it up front. You can't just wing it.
So
I,
Phil, let's
I,
unpack that a little bit, if you don't mind, because you had mentioned earlier too that the UL 4600, 80% of it can be applied anywhere. So maybe we can help people understand what exactly is it about a standard that helps us, even though it's not exactly going to help us get all the way there, but it can still, shine the light, so to speak. So maybe you can unpack that standard for us and what the recommendation is that comes off of that.
Sure. UL 4600 is not about how to build something that's safe. It's about how to decide if the thing you built turned out safe. And so it requires a safety case, a safety argument. Well, what do you mean by safe? And then how do you know you got there? Give me a structure. Walk me down all well, what about this? What about this? What about this? And a lot of it is, did you think of this? Did you think of this? Did you think of this? And there's a section on AI and ways AI goes wrong. There's a section on hardware dependability. There's a section on software quality, all these kind of things. And it says you just have to set forth a case for why it is you believe you're safe with a lot of granular detail so we can make sure you're not waving your hands. And some of them talk about running red lights. Yeah, okay, fine. You don't need that for medical devices, right? Unless it's the self-driving medication cart tray that has to obey it at intersections, right? Those are things, right? But most of it you can get rid of that. But the things about ways software fails and the ways hardware fail and how you use redundancy to make sure it's not redundancy theater that really know when the primary makes a mistake, it'll know it made a mistake and it will turn itself off, and the secondary pickup, that has nothing to do with cars. That's everything. So at a guess, 80% of the standard is about core, how to build safe, and there's a security chapter as well that says do security, but don't forget these other things that are sort of unique to embedded AI. So it's a way to draw this argument and have independent analysis that, really, you've got a really solid safety story and nobody's perfect. So we also know that if something goes wrong, you have instrumentation that's going to tell you what went wrong so you can fix it. That's what the standard does for you. And if you want to take 4600 and change it to medical, it's probably 20% of the words change and you're good to go.
Policymakers, they need to monitor the economy and the stock market and retirement plans, and that's their number one thing, as well as business leaders who are making decisions about AI strategies. And so I just want to point out that Steve and I gave a keynote at ISC2, the local ISC2 for CISSP certification. And one of my slides, which you'd helped me with, so thank you, Phil, was about how if one company had implemented UL 4600, they would have had a dramatic positive business market impact. So what they had seen was a reduction in their stock price by half. And then eventually what we saw is that it got dissolved. And so what I'm working to do, because this is absolutely true in medicine, that there is absolutely a business case for both security and safety, and that we need to lean into that, because those are things that decision makers understand.
Yeah, there's a challenge there that we saw in the self-driving car business that I think applies everywhere, which is security to a degree, safety to a degree. When you're in the move fast and break things phase of your company, it's basically assigned a value of 0, that it's not seen as worth investing in, especially up front. And even as you get in, you have to have a story. But the problem is that until you have the bad crash, there was no perceived value from having invested in it. And once you have, so you can say, well, we'll wait until the bad crash and then we'll start investing. But with Uber ATG and with Cruise now and with several other companies, what we've seen is the company does not survive the bad crash.
Yeah.
The big adverse event is fatal to the company. So a plan of we're going to sort of slow roll that and do the bare minimum and wait until something's on fire to put out the fire turns out not to be survivable for these companies. And so that's something to keep in mind, that's a tricky thing. Buying insurance won't help you if it's an existential event.
Yeah. I mean, some of this goes hand in hand with the culture of doing product development that's, come out of come out of the Bay Area, right? Let's be honest. You look at history, tech mostly came from Silicon Valley, and Silicon Valley was founded by people who crossed mountains to mine gold. And it's true. The
We're
fact
both
that there
natives.
is
So
in the VC community, kind of the attitude is 9 out of 10 of my investments will fail. I mean, completely. I will lose all my money, but I will make it back on that 1 in 10. And if
Well, that motivates you to not worry about safety and security, because
that's
9 out of 10
exactly
companies failed, but the 10th made it. So what's the problem?
that's exactly my point. And
Yeah.
I'm saying it's endemic in the attitude of the companies developing a lot of this. And I think it's if you're an entrepreneur, you need to be conscious of this because you're not the VC. You don't get to fail 9 out of 10 times. That sucks.
you never get to work in the
And
field again. It's not just the company, but yeah.
right. But you're going to have investors and things pushing you to take risks in all sorts of ways, and you've got to make really good judgments about these things. So it's understanding that it's endemic in the culture of how high tech new things are invented. I think entrepreneurs need to be conscious of that, and consumers of these technologies need to be conscious of this, especially with adopting early stage new technologies, because these usually are, the safety and security of these things is rated very low in how the companies developing them are weighting their odds of what they're investing in.
There's an additional dimension here that if you're in the consumer electronics or the cloud service, typical cloud service, if your product just implodes and does damage to everything, it's financial damage and some ticked off people.
Yeah.
But if you're doing embedded AI, real people are getting real hurt. And that's just a difference that the culture has not fully appreciated. I've spoken to folks who were working at companies after they had the fatality or the severe injury, and many of them did not really appreciate what it would feel like to be on the other side of that event where they contributed to the system. And it's very, very hard, especially if you have a history, if you've been making printers, or you've been, doing bank account services, home investment software or whatever. It's really hard to appreciate how much the world changes when you start controlling safety. Some of safety is control of release of the energy into the environment, and a bad release causes physical damage. People really don't appreciate it. Now medical people have more of an appreciation, but if the folks who are developing it are coming from this IT space that aren't used to embedded devices, it's a bigger cultural gap than they appreciate till they hit it.
So for the final question, I'm going to send this over to Steve first. Given this conversation about security and safety, what are your highlights from Davos?
From a security point of view, the big discussions in Davos are around the fact that this is not always self-inflicted. I mean, that's a lot of the sort of safety discussion. From a cybersecurity discussion, we are in an arms race. And I do think that even when we're building safety critical systems, you need to think about the security of those systems, because there are everyone from script kiddies who are teenagers in their basement with advanced AI tools and that they can now use for attacking your systems, all the way up to nation state actors where you have North Korea and China deploying very advanced AI systems in their offensive cybersecurity. And we are now in an active arms race of trying to figure out how to rush new AI technologies to market for defense at the same rate that people are using them for offense. Because we talk about the safety, the nation state hackers from Russia are not worried about the safety of the systems that they are using, and they are going to move fast and break things. And on the cybersecurity defense side, we need to move fast and aggressively and invest heavily to keep these systems safe, whether it's your IT systems, your corporate secrets, or your embedded systems that you're deploying in the field that somebody could be looking to disrupt people's businesses who are your customers or your users. And I think that's really, as we talk about this fourth industrial revolution, which was one of the big themes at at the event and is for WEF in general, that that arms race in artificial intelligence, much of it pivoting around cybersecurity, is a big deal.
Phil, any final comments from you before we close out?
Well, along those lines, one of the things we consistently see is people shortcut safety because they're in a hurry. And there are almost always ways to get better than nothing on safety. Maybe not perfect. I understand you don't need to be perfect to provide value. I completely get that. But people will say, oh, well, it's too hard, it's too expensive, we have a deadline, and use that as an excuse to do next to nothing on safety, where they could do, they're saying, well, we can't be perfect, so we're doing nothing, as opposed to saying, well, we're going to get a B on it. And by the way, we have a human and our strategy is as human operator, and they do the following thing, and we think that'll be okay, and if we're wrong, we'll fix it later. They just say, well, we can't be perfect, so we do nothing. We hear that story in safety over and over because we're in a hurry, because the threats are so, as Steve said, the threats are really serious. But that's not an excuse for doing nothing. There's always something you can do. You just have to want to.
Unbelievable. Listen, I call myself Stephanie Safety First Feels so, in all aspects of life. So I love the way you guys are thinking about this. This was a fantastic conversation. Thank you so much for really giving us a look behind what this is, because it's more than just self-driving cars. It is applicable to all these different things. And Steve, you do have to think about all of the ways that these things are being developed, because they have tremendous immediate implications, the way that the speed is going.
Yeah, thank you so much. That was brilliant, both of you, all of you. So.
Thanks, Sherry.
Thanks for having us.
Thank you all for watching. We'll talk to you soon. Bye-bye.